Here's a thought that should stop you cold. The most intelligent minds in human history, people who built cathedrals of mathematics, who mapped the stars, who split the atom, many of them believed in God. And yet, the very tools they invented, logic, evidence, reason, the scientific method, those same tools are now being used to argue that God cannot exist. Isn't that strange? The ladder that humanity climbed to reach the heights of understanding is now being used to knock down the very ceiling some people thought was heaven. So here is the paradox. If science and logic are the children of human curiosity, and human curiosity was supposedly placed in us by a creator, then are we using God's gift to disprove God? Or are we simply finally brave enough to look at the universe as it actually is, not as we wish it to be? That question is not simple, and anyone who tells you it is not being honest with you. Let's start somewhere ordinary, somewhere you've been 1,000 times. Imagine you're a child again. You're lying on the grass on a warm evening, staring up at the sky. The stars are just beginning to appear. One, then two, then suddenly thousands, and at some point the question arrives. It always does. It's almost like the universe plants it in you on purpose. Who made all of this? It's the most natural question a human being can ask, because everywhere we look in our daily lives, things that exist were made by something. A chair was made by a carpenter, a road was made by workers, a cake was made by someone in a kitchen. Your brain trained on millions of such observations builds a rule. Things that exist have makers. And so when you look at the stars, at the mountains, at the miracle of a single living cell that somehow knows how to divide and replicate and repair itself, your brain does what it always does. It applies the rule. It says this must have a maker. This is not stupidity. This is not primitive thinking. This is your mind doing exactly what it was shaped by evolution to do. Find patterns, find causes, find agents behind events. For hundreds of thousands of years, assuming there was someone behind an unexpected event kept you alive. The rustle in the bushes, assume a predator. The lightning bolt, assume an angry force. The flood, assume a will behind it. The God hypothesis at its root is a very human cognitive reflex. It is the mind doing what minds do looking for a cause. And for most of human history, it was a reasonable answer. When you don't have telescopes, when you don't have microscopes, when you don't have particle accelerators and quantum field equations, the universe looks designed. It looks intentional. It looks like someone drew the blueprints and set the whole thing spinning. The flowers bloom at the right time. The seasons turn with precision. The earth sits at exactly the right distance from the sun, not too hot, not too cold. Babies are born with 10 fingers and 10 toes, with hearts that beat and lungs that breathe. How could all of this be an accident? That feeling, that deep gut-level sense that the universe is arranged, is not something to be dismissed. It is the starting point of the greatest intellectual journey our species has ever taken. But here's the thing about journeys. They take you somewhere you didn't expect to go. Now, here is the question nobody asks. Or rather, here is the question people start to ask and then stop because the answer makes them uncomfortable. When we say God created the universe, we are saying something specific. We are saying there was nothing, and then a conscious, all-powerful intelligence willed something into existence. Fine, but then, and this is where people quietly change the subject, then who or what created God? The standard reply is God is eternal. God has no beginning. God exists outside of time and therefore needs no cause. All right. Let's hold that answer carefully because it's important. If we are willing to accept that something can exist eternally without cause, without beginning, if we are willing to grant that to God, then why are we not willing to grant it to the universe itself? Why is the universe always existed, or the universe emerged from a timeless quantum state, considered unsatisfying and in need of explanation? But God always existed is considered a perfectly acceptable stopping point. This is not a trick question. This is a genuine philosophical puzzle that has occupied serious thinkers for centuries. And the honest answer is there is no logical reason why an eternal uncaused God is more satisfying than an eternal uncaused universe, except that one of them has a personality and personalities feel more comfortable to human minds. We are pattern-seeking creatures. We are social creatures. We naturally feel more at ease knowing there is someone in charge than knowing there is a mindless process unfolding according to laws that care nothing about us. But comfort is not truth, and this is where science and logic begin to do something remarkable. They don't just offer competing answers to the same question. They begin to question whether the question itself was framed correctly. What if the universe doesn't need a creator? Not because we've proven there isn't one, but because the very concept of needing a creator breaks down when you look closely enough at the nature of time, causality, and existence itself. Stay with that, because the physics here is not just surprising. It is reality-altering. Let's talk about causality, cause and effect. It seems so obvious, so ironclad. Every effect has a cause. Every event was triggered by a prior event. This is the clockwork logic of the universe, or so it seems. Isaac Newton saw a universe that ran like a perfect machine. You set the initial conditions, you apply the laws of motion, and you can calculate everything that will ever happen. Deterministic, predictable, and implicit in that picture is a chain of causes stretching back to what? The first cause, the unmoved mover, the thing that started it all. This is actually a very old argument. It goes back to Aristotle, and for centuries it seemed airtight. If everything that exists was caused by something before it, then either that chain goes back infinitely, which seems absurd, or it terminates in a first cause that itself was uncaused. And that first uncaused cause, the argument goes, is God. It's logical, it's clean, it's structured, and on the surface it feels right. But here's what Newton didn't know. Here's what no one in the ancient or medieval world could have known. The clockwork universe, that perfect deterministic machine, breaks down. It doesn't just get complicated at small scales. It fundamentally, irreversibly breaks. When physicists began looking inside the atom in the early 20th century, they found something that shattered every intuition about cause and effect. They found that at the quantum level, events do not have definite causes in the classical sense. A radioactive atom decays, but when it decays cannot be predicted, not because we lack information, but because the universe itself does not decide in advance. The outcome is genuinely fundamentally random. Einstein hated this. He famously refused to accept it. He spent years trying to find the hidden variables, the deeper clockwork beneath the quantum fuzziness, and he failed. Not because he wasn't smart enough, because there is nothing there. This is not a gap in our knowledge. This is a feature of reality. And once you understand that causality itself, that bedrock principle that seems to demand a first cause, once you understand that causality is not a universal law written into the fabric of existence, but rather an emergent behavior that appears at the scales we happen to live at, the entire first cause argument begins to wobble. Here's where it gets strange, really strange. Not only does causality break down at quantum scales, but time itself behaves in ways that make the concept of a beginning deeply problematic. In Einstein's general theory of relativity, time is not a fixed stage on which events play out. Time is a dimension of spacetime, and spacetime can curve, stretch, compress, and under the right conditions, it can have a boundary, a beginning. Not a beginning in time, but a beginning of time. Stephen Hawking and James Hartle developed what's called the no-boundary proposal. The idea is this: if you trace the universe backward toward the Big Bang, time doesn't extend infinitely into the past like a straight road. Instead, it curves and closes the way the surface of a sphere closes. The south pole of the Earth doesn't have anything south of it. Not because something is blocking the way, but because south simply has no meaning at that point. The direction ceases to exist. Similarly, before the Big Bang may simply have no meaning. Not because something is preventing us from looking there, but because the concept of before requires time, and time, as a dimension of our universe, came into existence with the universe. Now let that land for a moment, really let it land. If time itself began with the universe, if there was no before, then the question, what caused the universe, may be as meaningless as asking, what is south of the South Pole? It's not that we don't know the answer. It's that the question contains a hidden assumption that there was a before which may simply be false. And here's the twist inside the twist. The God hypothesis doesn't escape this problem. If God created the universe before the universe existed, then God acted in a time that by our best physics did not exist. The Creator exists in a temporal framework that the physics says wasn't there. You can try to say God is outside of time. But then what does it mean to act, to will something, to create? All of these are processes. All of these unfold in time. A timeless act of creation is not something our logic, the very logic used to construct the argument, can actually process. Let's imagine something together. You are floating in absolute nothingness. Not dark nothingness, because darkness is just the absence of light, and light is something. Not cold nothingness, because cold is just low thermal energy, and energy is something. True absolute nothingness. No space, no time, no laws, no quantum fields, no mathematics, nothing. Now in this nothingness, can something happen? Your immediate intuition is no. Nothing can happen because there is nothing to make it happen. No cause, no effect, no before, no after. But here is what quantum mechanics tells us. In our universe, the quantum vacuum, the lowest energy state of space, is not empty. It sees with virtual particles that pop in and out of existence, borrowing energy from uncertainty itself. It fluctuates. It does things without a cause in the classical sense. Now, you might say, but that quantum vacuum exists in space and time. It's not true nothingness. Fair, absolutely fair, but here's the question. Is true nothingness actually stable? Is it possible for absolute nothing to simply stay nothing? Physicist Lawrence Krauss and others have argued that nothing is fundamentally unstable. That nothingness, if the laws of quantum mechanics apply in any sense, even at the pre-universe level, would naturally and inevitably fluctuate into something. Not because something pushed it, not because a creator willed it, but because nothing is the least stable state possible. Now imagine you are in that nothingness, and suddenly, without any cause, you can point to, without any actor, without any intention, a fluctuation occurs. Space begins. Time begins. Energy erupts. The laws of physics crystallize out of the mathematics of symmetry. The universe appears, not created, not caused, simply happened. This is not science fiction. This is the frontier of serious cosmological physics, and the implications are not just scientific. They are deeply, profoundly philosophical. Because if the universe can arise from nothing without a cause, then the entire Structure of the God argument built on the foundation that everything needs a cause collapses from the bottom. Let's build this understanding in layers because the physics here runs deeper than most people realize. At the first layer, the layer of everyday experience, causality seems absolute. You drop a glass, it falls. A spark ignites fuel, the engine runs. Every effect follows from a cause. This is classical mechanics. This is Newton's world. Reliable, predictable, magnificent. But go smaller. Go to the molecular layer. Here things are still mostly predictable, but randomness begins to creep in. The path of a single molecule in a gas cannot be perfectly predicted. Statistical mechanics tells us we can know the average behavior of billions of molecules. But any single molecule dances to quantum rules underneath. Go smaller still. Go to the atomic layer. Now we are in the world of electrons, protons, neutrons, and here the rules change fundamentally. Electrons do not orbit the nucleus like planets orbit a star. They exist in probability clouds, smeared out regions of possibility. An electron is not somewhere until you look at it. And when you look, the act of looking itself changes what you find. This is not a limitation of our instruments. It is written into the structure of reality by the Heisenberg uncertainty principle. Go smaller to the subatomic layer. Quarks, gluons, the strong nuclear force binding the nucleus together. At this level, the quantum field theory takes over. Particles are not little billiard balls. They are excitations, ripples in quantum fields that permeate all of space, and these fields are never truly at rest. They fluctuate. They hum with zero-point energy, energy that exists even at absolute zero temperature, energy that cannot be removed because it is baked into the uncertainty of the universe. Now go to the cosmological layer. Zoom out to the scale of the universe as a whole. Here general relativity governs. Space curves in the presence of mass. Time flows at different rates depending on gravitational fields. The universe is not static. It is expanding, and that expansion is accelerating, driven by a mysterious dark energy that we can measure but not explain. At this layer, the concept of the universe having a single beginning in ordinary time becomes complicated by the curvature of space-time itself. The Big Bang was not an explosion in space. It was the expansion of space itself from a state of infinite density, a singularity where our equations break down and our current physics cannot tell us what came before. And there is one more layer, the deepest layer, the layer of mathematics itself. Why do mathematical laws describe physical reality at all? Why should the universe obey equations? Why is there something rather than nothing? These are questions that science in its current form reaches toward but is not fully answered. And this is important to acknowledge honestly. The frontier of physics is not a place of smug certainty. It is a place of breathtaking uncertainty and genuine wonder. Now let's travel, really travel. Start here in your chest. Your heart is beating about 70 times a minute. Inside each heartbeat is a cascade of electrochemical signals. Protein molecules folding and unfolding. Ion channels opening and closing. Inside each protein molecule, atoms bonded by shared electrons. Inside each atom, a nucleus surrounded by that probability cloud we talked about. Inside each nucleus, quarks bound by the strong force exchanging gluons at speeds approaching light. This is you. This is happening right now inside your chest while you watch this video. You are a walking quantum event, a temporary eddy of order in a universe trending toward disorder. Now zoom out. You are sitting on a planet. That planet orbits a star, our sun, a nuclear furnace, converting 4 million tons of mass into energy every second via the same quantum tunneling effects that govern radioactive decay. Without quantum mechanics, the sun would not shine. You would not exist. Zoom out further. Our sun is one of approximately 300 billion stars in the Milky Way galaxy. The Milky Way is one of at least 2 trillion galaxies in the observable universe. The observable universe, everything we can in principle see, spans about 93 billion light-years, and that is only the part we can't see. The full universe may be vastly larger. Some models suggest it is infinite. Zoom in now, past atoms, past quarks, to the theoretical scale called the Planck length, 1/6*10 of -35 m. At this scale, space and time themselves may lose their smooth continuity and become foamy, granular, a quantum fuzz of geometry. This is the scale at which gravity and quantum mechanics must somehow be unified, a problem that remains unsolved, the deepest open question in physics. Now, zoom out to the multiverse. Some interpretations of quantum mechanics, some models of cosmic inflation suggest that our universe is not alone, that there may be a vast, perhaps infinite ensemble of universes, each with different physical constants, different laws, different histories. In this picture, we live in one of the universes that happened to have conditions compatible with our existence, not because it was designed for us, but because we could only ever find ourselves in the universe where we could exist. This is the anthropic principle, and it is not a trick or a cop-out. It is a serious piece of reasoning that changes how we think about the apparent fine-tuning of our universe. One of the most powerful remaining arguments for a designer, at every scale, from the quantum fuzz of the Planck length to the vast web of galaxy filaments stretching across the observable cosmos. Universe operates according to elegant mathematical laws that require no author. They simply are, and they are breathtaking. Here is the realization, the one that changes everything. The God argument, in all its sophisticated forms, ultimately rests on the assumption that existence requires explanation from outside itself, that the universe left to itself cannot account for its own existence, that there must be something beyond, a mind, a will, a creator to explain why there is something rather than nothing. But what science and logic together have revealed is this: the universe may be self-contained in a way that makes the concept of an external explanation not just unnecessary but incoherent. Think about what a self-contained explanation looks like in mathematics. A perfect sphere needs no external reference to define its shape. The definition is built into itself, the laws of mathematics. Why 2 + 2 = 4 do not require a mathematician to make them true. They are true in a way that precedes and encompasses any thinker. What if the laws of physics are like that? What if the universe is not a contingent thing that needed to be created, but a necessary thing? Something whose existence follows from the mathematics of possibility itself. The physicist Max Tegmark has proposed exactly this, the mathematical universe hypothesis. The idea that mathematical existence and physical existence are the same thing, that every mathematically consistent structure exists, and we live in one of them. This is a radical idea. It may be wrong, but notice what it does. It replaces the question, why does the universe exist, with why wouldn't it? If mathematical structures exist necessarily, and our universe is a mathematical structure, then the universe exists necessarily. No creator required, no external cause, no first mover. And here is the most important thing to understand. This is not atheism as a belief system. This is not a replacement religion. This is the logical consequence of following the evidence honestly, rigorously, without flinching. Science does not say there is no God. Science says every time we have looked for supernatural intervention in natural processes, we have found natural processes. Every time we have invoked a creator to explain something, lightning, disease, the diversity of life, the structure of the cosmos, we have eventually found an explanation that required no creator. The pattern is consistent, and the honest mind notices patterns. But let's be careful here. Let's be honest with ourselves. Science is a method. It is perhaps the most powerful method for understanding reality, that our species has ever developed, but it is a method with a specific domain: the natural, the measurable, the testable. And there are questions that may lie outside that domain, not because they are unanswerable, but because they may be unanswerable by any method available to finite minds. Why is there something rather than nothing? This is not a scientific question. It is a metaphysical one, and the honest answer from anyone, scientist or theologian, is we don't know. What gives the laws of physics their particular form? Why these laws and not others? Why does mathematics describe reality at all? These questions sit at the edge of what human thought can reach, and there is something important to say here, something that gets lost in the heated debates between science and religion. The universe, whatever its ultimate origin, is genuinely, staggeringly beautiful. The fact that we can understand it at all, that the neurons in a human brain assembled by billions of years of blind evolution can grasp the curvature of spacetime and the dance of quantum fields, that is not a small thing. That is extraordinary. You are made of atoms forged in the cores of stars that lived and died before our sun was born. The iron in your blood was made in a supernova explosion billions of years ago. You are, in the most literal sense possible, made of star stuff, and you are conscious. You are aware. You are here in this moment thinking about the nature of existence. Whether or not there is a God, whether or not the universe has a purpose, this is remarkable. The universe has produced something that can contemplate itself, that looks back at the stars and wonders where it came from. That is either the greatest accident in the history of existence or the most profound thing that has ever happened, and perhaps it is both. So where does this leave us? The God argument in its classical forms has been seriously challenged, not by cynicism, not by arrogance, not by a desire to destroy meaning, but by the honest, patient, rigorous application of reason and evidence to the deepest questions we know how to ask. Quantum mechanics has undermined the principle of universal causality. General relativity has complicated the concept of a beginning in time. Cosmological physics has shown us how universes can emerge from quantum fluctuations without external causes. The anthropic principle and the multiverse offer explanations for apparent fine-tuning that require no designer. Mathematical Platonism raises the possibility that existence itself may be necessary rather than contingent. None of this proves that God does not exist. That is important to say clearly and honestly. Absence of evidence is not always evidence of absence, and there are domains of human experience, meaning, love, beauty, consciousness that science describes but may not fully explain. But what science and logic together have done is this: they have closed the gaps. One by one, the places where God was needed as an explanation have been filled by understanding, and the God that remains, if one remains, is not the God of the gaps, not the creator who built the clockwork universe, not the lawgiver who set the constants of physics, but something far more abstract, far more mysterious, far more silent. And here is the most mind-bending thought of all: you are the universe becoming aware of itself. The atoms in your body have been part of stars, oceans, dinosaurs, ancient forests. They will be part of other things after you. You are a temporary pattern in an eternal flow, a brief, beautiful eddy of consciousness in a cosmos that is almost entirely unconscious. And in this moment, right now, you are the universe asking itself the hardest question it has ever asked. Why am I here? And maybe, just maybe, the asking of the question is itself the most extraordinary thing that has ever